Today, we're going to discuss about ionization energy in periodic trends in properties in periodic classification of elements, Unit 8, Chapter 8 in chemistry. Already, we have discussed the periodic trends in properties, atomic radius and ionic radii. Ionization energy. Now, we're going to discuss about the ionization energy. Ionization energy is the minimum energy required to remove an electron from an isolated gaseous atom in its ground state to form a cation. So, ionization energy is the least energy. Why the least? Minimum energy. Okay, the minimum energy to remove the electron in the gaseous state, that is in the gaseous atom in the ground state to form an cation. So, removal of electrons in the gaseous atom to form a cation. For this, you need an energy. That energy is called ionization energy. The ionization energy is otherwise called as ionization enthalpy, and it is measured in kilojoules per molecule. So keep it in mind. They may ask this in 1 mark, kilojoule per mole. Higher the ionization energy, it is more difficult to remove the electron. So if you have more ionization energy means the electron removal is difficult. It is difficult to remove when the ionization energy is more. It is in high. During the high ionization energy, the electrons will not be removed easily. As the atomic size decreases from left to right in a period, more energy is required to remove the electrons. So you can see, so based on the atomic size decrease in a period, okay, decrease in a period from left to right, okay, from left to right, it decreases means the ionization, that is the energy, ionization energy will be more for the removal of electrons. So what means? The ionization energy increases along with the periods. So along the period, the ionization energy increases. See here. So the ionization energy increases along the period. But down the group, the atomic size increases and hence the valency electrons are loosely bounded. So in groups, the atomic size increases. So the atomic size increases due to the increase from the down, that is from the down group. The atomic size increases. Due to this increase, the valency shell electrons are loosely bounded. So they are loosely attached. So they are loosely. For loosely attached electrons, less ionization energy is enough to remove the electrons. So to remove the electrons, see here. So they require relatively less energy for the removal of electrons. So thus the ionization energy decreases down the group in the periodic table. So based on the groups, the ionization energy decreases in the periodic table. According to the period, the ionization increases along the period, but in group it decreases. Okay, decreases, and you can see the fluctuations here. So the fluctuation, how it increases according to the size. Hydrogen and helium, it is increased. So this is one period. The next period, lithium to sodium till argon. The next one is potassium. Like that it increases. The atomic size based on the ionization energy, it increases. It shows the fluctuations. Okay, fluctuation. This is a graph. This is not in your book. So just for understanding how the fluctuations are taking place and how the energy is increasing, increasing in the period level. Okay, they had given, and you can also see some here in this the group level decreasing and the period level increasing methods. Okay, keep it in mind. In the ionization energy, this energy is used to remove the electrons from the cation. So, for the removal of electrons in the gaseous state, that is in the gaseous atom, in the ground state, to form a cation. And it is also known as ionization enthalpy. And it is measured in kilojoules per molecule. High ionization energy, if it has an ionization energy, it is difficult to remove. What is difficult to remove? The electrons are difficult to remove from an atom. Okay. So, based on the atomic size, if the atomic size decreases with the period, the ionization, that is, it need more ionization energy to remove the electrons. Okay. But that is, so the ionization energy increases along with the period. But in groups, the atomic size increases from down the group. Okay. Down the group. Due to that, the electron valency shells are loosely bounded. So, because of loosely bounded one, it is easily remove the electrons. So, for that less energy is needed. So, because of that, the ionization in groups, it decreases. So, the ionization energy in groups decreases in the periodic table. Hope so you are understand with the topic. Give a thumbs up, share and subscribe to Science Easy Tech channel.